Yes, I think, hopefully, success. So, welcome everybody. For the past couple of days, I've been converting my living room into a live studio thanks to Northampton Open Media for getting me all this gear. Hopefully, we can use this space to learn some things, keep refreshed on the things that we've kind of understood throughout class, and have some fun. Not going to be seeing each other for 3 weeks is kind of bums me out, but hopefully we can exchange some thoughts and I can answer some questions. We can bring on a couple of familiar faces and just have some fun. Okay, so today I wanted to talk just basically a review for my photo class on lenses. I get a lot of questions about what lens should I get? Why is this lens so expensive compared to this other lens? I have these lenses and how do I use them efficiently or creatively? So, what we're going to do is I'm going to pop over here and I want to take a look at just what focal length is and what's going on with some lenses. I have some lenses over here that we're going to take a look at as well. But let's take a look at a couple of things that we need to know first. So, focal length. Well, what is focal length? Focal length in its definition is the distance between the center of a lens or curved mirror and its focus. So there's a lot going on there. Definition aside, what I really like is just seeing this picture. Okay, so what is focal length? Well, you can see over here that it's a distance between something. So what is going on here? So every lens is going to have a whole bunch of different lens elements, and you can see that there. It's convex in curved lens pieces of glass, just glass in there which takes the light in and bounces it to the back of the camera, and it hits what we call the camera's sensor. Okay, that's back here. So the camera's sensor, just in kind of layman's terms here, is just a bunch of it's millions of kind of tiny buckets that collect light, and they turn that into a digital signal, and from there you're able to get to have a X megapixel picture, yada yada. But just for the layman's terms, all you really need to know is that with lenses, the focal length is the lens, the space between the back lens element and the sensor. And that on some lenses it can't change, which we call a prime lens. And for some lenses we can make that vary, which is a zoom lens. So, head back over here. Whoop. So, focal length is measured in millimeters, and we can see what that is based on where we are on our lens. So, let's come on over here. We're going to take this lens, for instance, okay? This lens right here is a Canon 24 to 70 millimeter lens, and we can see that it actually says it right here. So if you're kind of looking at a lens, I like to just examine the lens, see what's going on. We can see a couple of different places where that information is. But for this lens, it is a 24 to 70 millimeter lens. Now, again, what I was saying before, there's two types of lenses. One that is fixed, you can't move it. So you might have a 50 millimeter lens. A 50 millimeter lens is a lens that cannot move. You can't zoom in or zoom out. You're always at 50 millimeters. So what you're going to have to do in that situation is you're going to have to move your own body. We're going to get talking about working the shot and this, that, the other thing. But you're going to physically need to move your body with a prime lens. A prime lens cannot zoom like this. Okay? So let's take a look at another lens. This one right here is a Tokina 11 to 16 millimeter lens. So you can see that this one's 24 to 70. This one's 11 to 16. So what is going on with those numbers? Why are some of them lower? Why are some of them bigger? Well, if you go back to our original thing over here, the focal length, the higher the focal length, the more that that lens element is getting away from the sensor. So a higher focal length is going to be out over towards here. So you're going to have longer lenses. So if we go back over here and we take a look, this lens right here, the 70 to 200, you can see it's physically longer than the 11 to 16 because that lens element is going to increase like that. So why do those numbers matter? Let's go back over here and we can see that lenses are going to affect three different things, particularly field of view, depth of field, and what we call compression. And so just taking a look at this, I really like this as an example right here. So let's take a look at this for a second. The picture looks kind of similar in all aspects, right? So it's kind of the same subject, and the subject is the same size, but this is really where you can start to see the difference over here on what's going on with all of these settings. So let's first start out with field of view. Okay, so field of view, or what we call angle of view, is actually how much we can see in the frame. So take a look. I'm going to zoom in a little bit. Whoop. Go back over here. And I'm going to zoom in a little bit and take a look. So let's take a look at 12 millimeters. So 12 millimeters, we are, it's really close to the sensor. And so what's happening here is that we can see a lot of what's going on in the shot. We can see the tables over here. We can see this this plant in the top of the roof over here. But as we start to zoom in, we see less and less of the actual space or environment that we're in. Now, I'm also going to bring up another one because this is really field of view comparison. So let's take a look. This is one of my favorites. It's the barn. Let me see if I can find it. Focal length comparison. And ta-da. So let's take a look at this guy for a second. So here, I'll zoom out a little bit. Over at 18 millimeters, we are really zoomed out. That's a kind of terminology that we kind of casually use. So we're really zoomed out here, and we can see this entire, we can see the mountains here. We can see this, this fence. We can see that tree. So we can see a whole bunch of stuff here. But that barn is really, really small in this picture, okay? So as we increase our focal length, as we kind of zoom in, we start to amplify, we start to magnify everything in our shot, but we also start to crop out things, okay? So eventually, and I'm going to change, just go back for a second right here. Boop. There we go. So now we can see this a little bit better. So as we increase our focal length, we start to zoom in, but we start seeing less in the frame till eventually it gets to the point where you can see that red barn. Again, we could be using an 18 to 300 millimeter lens. They actually, I think Sigma makes one. So you can either have this, or you can zoom all the way in and sacrifice seeing that mountain and seeing the sky and seeing some of that other stuff. So that's the power of your focal length. You can have wildly different pictures with a zoom lens on. You can create wildly different pictures, and you can also see how this starts to help you out in whittling down your composition. So that's what we're going to talk about in later videos. How do we want to simplify things, and what is the clear subject and background here? Is the clear subject is what we're going for something like this 35 millimeter where we're trying to do a nice landscape picture and the barn is kind of in that background and small? Or do we really want to emphasize that those two barns and we don't really care about the mountain and everything? It might be, pictures for a client that is on their horse farm, for instance. So we might want to see the sprawling stuff at a 35 millimeter, but we might want to zoom in, get out all the clutter, and focus on those red barns. So that is what we call field of view. Going back over here. Whoop. So back over here, what we have is focal length. The focal length is going to vary. We have zooming. If you have a number range on a lens, that is it's a zoom lens. If it only has one, so like a 24 millimeter, you might see that in our kits, or a 50 millimeter. Those are prime lenses, and you'll have to move your body in order to get different shots. All right, so that is field of view. As we zoom in, you start seeing less. You start cropping out. So now let's go over to depth of field. So depth of field, we're going to have another entire kind of examination of depth of field here. But it's important to know that for depth of field, let's get over here and let's take a look back over here at our wonderful comparison of all these shots. So, do you notice anything that's going on with the background and how clear it looks? So at 12 millimeters, right, there's some distortion and stuff that's going on here, but you can see all of the chairs and everything that are going on in the background, right? As we increase our focal length, things start to get blurrier to the point where we get all the way to this 280 millimeter and we can't distinguish anything in that background. Now notice he is still clearly in focus, but that background is really, we kind of can put together that they're in some sort of indoor space, maybe a cafe, maybe some sort of academic building, but you can't, the background is really blurry. Now this can help and can hurt you. So let's take a look at that. So as you increase your focal length, you are making your depth of field, and this is where it can kind of be a little confusing, right? So we're talking about depth of field and field of view and all this stuff. So depth of field, as you increase your focal length, so if I was increasing my focal length, I would go from 70 to 200, right? That's increasing my focal length. And if we're thinking about what focal length is, here's the sensor. I'm increasing from 70 to 200. I'm increasing the distance from the sensor to that back lens element. Ooh. So I'm zooming in, but what's happening is that your focal point, the time it takes from things to get really blurry, starts to decrease. So as you zoom in, you have a shallower depth of field, okay? So shallower depth of field is going to help out in certain circumstances. So if you take a look at, if we go back over here, Sometimes you want to have that shallow depth of field because this is particularly the case in, for instance, senior pictures. So if we're looking at over here, let me go back over here. If we're looking over here, we want to have that shallow depth of field because we want to be very clear on what our subject is. We understand he's talking to a guy, but even the guy is blurred from that depth of field. The background, we have a gist of what's going on, but we really want to focus on the person. Also notice that the person here is taking up a lot of the composition of the frame. So this for my video students, this is really important because you want that you're not only showing that subject is the clear, we're focusing all attention on him because of the composition, but also because of that shallow depth of field. We don't want any distractions. So if we go, for instance, up here, you can see how in this one, in that 12 millimeter, things are busy. He gets lost inside of everything that's going on, especially with all those kind of geometric lines and everything, but we'll get into that later. So going back over here, as we increase our focal length, we have our field of view starts to narrow. So I'll put this here too. Increase focal length equals, whoop. I keep on hitting the button over there. Increase focal length equals narrower field of view. So if you increase you have a shallower depth of field. Yep. I have my hotkey set to the equal sign being switch cameras, so that's what's going on over there. But increased focal length, you also get a shallower depth of field, so that background is more blurry as you increase. And now we're on to compression. So compression is a kind of weird one. So if, for instance, come on back over here. I'm going to come on to this camera. Okay, so we're going to take a look at in a second those examples again. But what happens with compression in perspective is as you increase your focal length, the background actually looks like it's getting closer to you. And it's kind of weird. So let's take a look at what that means, what that looks like. So let's take a look right here. So let's focus on something here that we can see throughout all of these. So it looks like we have a good grasp on this red lamp in the background. So watch what happens through the focal length as we increase our focal length here. Oh, looks a little closer. Looks a little closer, but let's jump down to over here. So look at this red light here and here. Look at those lights, okay? So as we increase our focal length, as we zoom in, that red light appears to get closer to us. It starts getting larger in the actual shot. So this is a good kind of example right here. So see the light up here at 25? We almost double that. Go down here. And now it looks like it's getting closer. So this is, it's actually really, it's really interesting. And what you can do is you can oftentimes use that to just draw things closer to you, and it also is good for thinking about the size of objects. With a wider lens, with a shorter focal length lens, you have objects are going to, if you're closer to an object, objects are going to get smaller quicker. It's called dwindling size perspective. So they're going to get smaller as we go along. So you can use your focal length to, if you start zooming in, you can make things look a little closer to what relative size they are, but you're also drawing your background in as well. Cool. So let's just go back over here for a quick review. So focal length is the distance between the lens, the kind of like back lens element, and the sensor of the camera. The sensor is the camera is the mechanism of the camera that collects light and changes collects all the light photons and changes that into a digital signal, and that's how we have our digital photos. If you you can change the focal length, you can change the distance from the sensor to this back lens element with zoom lenses, or if you have just a fixed lens. So for instance, we were talking about the 50 millimeter, that is a prime lens. It's measured in millimeters, and it has three key effects. So as you increase your focal length, you're going to be able to zoom in. But you're going to, as you increase your focal length, you're going to narrow your field of view. So back in the barn picture, you're going to see less in the frame, but you're also going to have a blurrier background. Increase in focal length is going to have a blurrier background, a shallower depth of field, and an increase of focal length is going to cause more compression. That background is going to get closer. So this light that we were talking about comes back. And those can really, like, if we come back out, those can have a wild effect on what's going on here. So if we take a look, this, we can see everything. We can see this entire environment. We get down to here, and we just are focused on that guy. So let's see if there are any questions. So we got, thanks, Nico. Nico is complimenting me on the setup. I was actually, I think I was up until 2:30 last night trying to get this thing going. And we got everything figured out. There's crazy things going on. I have the computer's connected to the HDMI of the TV. It's an extended screen. We're recording this. We're streaming it live. We're doing all this stuff. I have this whole bunch of stuff under me that's going on. So there's a lot of production going on right now. But hopefully people are going to get stuff out of this. And I definitely want to get some alumni and other professionals to just have kind of shoot a Q&A, get the ball rolling on all of this. So hopefully you liked it. If you have any questions, let me know. And we'll go from there. Cool. Thanks, everybody.